there, welcome back. Today we are starting Unit 3. You've had this packet in your folder for a really long time. So see if you can dig this out. Pause me when you find it. But it's the one that looks like this. Remember, there's 2 packets for Unit 3. Just the one that says functions. It's got this little function. It's called the function machine on the bottom. And then turn to the first page. Okay, actually, let me get this out of the way. It has been a little bit of a time since we've had a video lesson because we've been doing a lot of review. So I'm a little out of practice. Here we go. So we are going to kind of go over these definitions, and then I'll explain them in terms of Emily and Stephanie. If you remember that story, that intro story that we did last in class, and then we will go through some practice problems. Okay. So right now, what we're going to do today is look at a relation. So these are relations. Stephanie works, she inputs hours, she gets out money. So there's a relationship between her time in and the money that she gets out of it, right? Emily also puts in time and gets out money. So we just, like we said the other day, we just started kind of writing down, if they were to write down what they earned based on how many days or how many hours they worked, this data that they collect, that's called a relation. Now, only one of these two we would then call a function, right? Only one of these two girls, or 2 sitters, could predict how much money they're going to make based on how much time they put in. And do you remember which one was the one? So if you look here, Stephanie worked 5 days one week and got paid $125. But another week, I didn't have my cash. So I had to pay her $140. Remember, the ATM only comes out in multiples of 20. And we're not going to slight Miss Stephanie because we love Miss Stephanie, right? So she worked 5 days the next week, and I wound up paying her $140. What's another $15? Helps her out, no big deal. But this means that when she works 5 days, she's not really sure, is she going to get the $125 or is she going to get the $140? Now, Emily, every time she works 4 hours, she's going to get $40. She's $10 an hour all the time. So she works 5 hours, she's going to get $50. She works 4 hours again. Every time she works 4 hours, she will get $40, okay? So we're going to make this look a little bit more formal, and we're going to just assign X and Y values. We're going to label our data table. I did not do that in class. And so if you take a look at the first line here, it talks about what a function is. So a function is a type of relation, okay? A function is a rule that assigns each input, okay? So in our case, this would be how much time they put in. Exactly one output. Okay, so a function is a rule that assigns each input exactly one output. So if you take a look at our little case here, this input of 5, if she puts in 5, say days, she could either get out 125 or she can get out 140. So this input of 5 has more than one possible output. That is not the case for Emily. Emily, if she puts in, so let's look at the 4 repeated here. Every time she puts in 4, there's only one possible outcome. When she puts in 4 hours, what is the output for Emily every single time? It is 40. So that's what they mean. A function is a rule that assigns each input exactly one output. You know what's going to happen, okay, if you put in 4 hours for Emily. So Emily is a relation that could also be called a function because of its predictability. Stephanie's data, there's a relation, she gets paid, but we do not pay her using a function rule, really. So functions occur when every x value is associated with exactly one y value. Same exact thing. So instead of saying input and output, sometimes I say x value and y value. Again, every time you put in an x of 4 for Emily, you're going to get out 40 every single time. For Stephanie, it's unpredictable what she's going to get out if she puts in an x value of 5. Okay? To test whether or not a table or set of ordered pairs represents a function, look to see if each input or x value has exactly one output or y value. Gotta move this. Okay, so let's practice on a different set of data, right? So this is a relation. You have inputs and outputs, or x values and y values. So you're going to look through here and see if any of these x values even repeat. So you put in a -2, you get out 7. So, okay, good. -1 comes out of 1, 0 comes out of -1, 1 comes out of 1, 2 comes out of 7. So is this a function? So this is where you're going to get tricked. The fact that the y values have 2 1s in it might throw you off, but think about it. If this was the vending machine, okay, remember the vending machine? If you press A1 and you don't know whether or not you're going to get a Twix or a Takis, that is bad, okay? But you can have A1, A2, and A3 all stocked with Twix. And what matters is when you press A1, do you know what you're going to get out? So if you come back down here, your eyes are probably, and maybe they didn't go to it, but this is typically where kids get tripped up. When you put in -1, what are you going to get out? A 1. If you put in 1, what are you going to get out? You're going to get out a 1. So you know what you're going to get out. It's okay that these two x values put out the same y value. So this is a function. So determine whether or not the following representations are functions. Explain your thinking. So yes, this is a function. Yes, this relation is a function. My dog is snoring so loud. Can you hear him? Of course, he stopped now. Because, and this is, you're gonna, oh my gosh, you're gonna say this so many times. Because each x value, or each input has exactly one output. Let's use that. Each input has exactly one output. Alrighty. So now, this is what they did. Same thing, but they just put it in ordered pairs instead. So this is an x value. When you put in -2, you get out 1. When you put in 3, you get out 11. Okay, the next time you put in a -4, you get out a -3. But this right here, this said when you put in -2, you got out 1. That means if this is a function, every time you put in a -2, you should get out a 1. And look over here. The second time -2 was input, you got out an 8, which means there are 2 possible outputs for this input. That means it's not a function. So no, this relation is not a function. Why? Because the input of -2 has 2 possible outputs. Okay. My nose always runs in the morning. I'm sorry. I blew my nose a little bit. I'm drinking my coffee super early. I'm looking down. So sorry about that. Okay. There's another way that data can be represented, and that is with a graph. And there's I would call it like a shortcut way of figuring out whether or not the data in the graph is a function. So instead of like figuring out what points were on the graph and making a data table, you can just use this technique. It's called the vertical line test. Guaranteed, I'll have to explain all of this to you again in class. So hang in there, because remember, it takes like 10 times to understand something. And right now you're getting like your first real blast of it. So it will take time. So you're getting value out of it, but I do not expect you to be like, 100%. If a graph represents a function, it should be able to pass what's called a vertical line test. Whoa, this foot's in the way. This means that any vertical line drawn on the graph should intersect the graph at exactly 1 point. So what does that mean? Okay, come down here. See this? So vertical line is up and down, right? Oh, that is terrible. That's a vertical line. So look at, if I drew a vertical line right here, this is your graph right here. These are your axes. So I'm talking about this curvy line right here. If you draw a vertical line like this, how many spots does it intersect this curvy line? Just right here. If I draw the vertical line here, it intersects once. Draw the vertical line here, it intersects once. Draw the vertical line here, it intersects once. There's no way you can draw a vertical line and have it pass through this curvy line, this graph, more than once. So yes, this is a function. Because it passes the vertical line test. Oops. Oh, there goes my backwards writing. Okay. Now, let's compare that. It might make more sense when you see what's not a function. So this curvy line goes more like an S. So if you draw a vertical line right here, how many times does it pass through the graph? This is the graph, okay? It passes through 1, 2, 3 times. This is not a function because it does not pass the vertical line test. No, this is not a function. I should say this relation is not a function, but I don't say that as much with graphs. This is not a function because it does not pass the vertical line test. Okay, next one. Does this pass the vertical line test? Is there, so this is what we're looking at. We don't remember, just ignore these axes. I'm not talking about that. I'm talking about this diagonal line right here. If you draw a vertical line here, passes through it once. Vertical line here, passes through it once. There's no way you can draw a vertical line and have it pass through this line more than once. You can only intersect 2 lines at one location, right? So this is a function. And then give it a little smiley face. I'm not going to finish the explanation because I don't want to go over too much time. So complete the exit ticket attached to this, and I'll see you tomorrow.